So there's my learning target, to understand the properties that describe solutions in terms of concentrations, solutes, and solvents. We've been dealing with that all along with this phases and mixtures. Create a solution and a dilution of a known concentration. Determine the concentration of an unknown solution. And finally, we need to be able to calculate the concentration of a solution. Now, as I look at this right here, I started out with the molarity equation. So I know that the molarity of a substance is equal to the moles of the solute, okay? The moles of the solute right here, divided by the liters of solution. Now, when we're talking about dilutions, okay, I have manipulated my equation down here. And you notice, okay, you notice that I have a V instead of the liters of solution. So right here I have a V instead of liters of solution. Now, the reason is it does not matter what I have my volume in, just so that I am consistent. Could I have liters? Well, yeah, that's basically what our molarity says. Okay. Could I have milliliters? Yes, if I have milliliters for both of them. Okay. Could I have, I don't know, 5-gallon buckets? Will that measure a volume? Yeah. Just so I'm consistent, I could have 5-gallon buckets. So my unit is not important. What is important is that I'm consistent with it. Now let me ask you this. Is a drop a volume? Yeah. Okay. So could I use drops? Absolutely I could. So you're going to see at times for these volumes, we're going to use drops. We'll probably use that more when we're talking about titrations, acids and bases later on. Okay. But the volume, just so we're consistent, we could use milliliters, so to speak. We could use drops. We could use liters. Now, when I manipulated my equation, I had M1V1 equals moles 1. M2V2 equals moles 2. So I have just solved each one of those molarity equations for the number of moles. Now, if you remember yesterday, when we did our little dilution demo, I had a little bit of water and I added 2 drops of food coloring, right? Then I put a bunch of water in there, but I still had 2 drops of food coloring, right? So the whole idea, we related that to moles, all right? When I dilute that particular molarity, I'm not changing the number of moles, am I? The moles are the same. So when I look at this and I make a dilution, the moles of 1 right here should be equal to the moles of 2. So those 2 are equal. So now, where does that get us? And I believe this is the transitive property, but don't quote me on that. I don't know my math properties that well. But if I look at this and I say A is equal to B, and B is equal to C, right? That tells me that A is also equal to C, right? So if A is the M1V1 and C is the M2V2, I can come up with my dilution equation right there, that if the moles are both equal, then M1V1 is equal to M2V2. Now that is, ladies and gentlemen, that is the equation that we're going to use to calculate these dilutions. Okay. Now, here is the very first example. I'll give you a second to copy it down, and then we will talk about it. The problem states that if you dilute a 175 milliliter solution of 1.6 molar solution of lithium chloride, okay? So I have 175 milliliters of a 1.6 molar solution, and I diluted it to 1 liter. Determine the new concentration of the solution. Now, I am actually doing a dilution here. So, what do you think about my molarity? Will it go up or will it go down? It should go down, right? So I should have a value that is less than 1.6 molar. Now, the first problem that I see is that I have this one labeled in milliliters and this one is labeled in liters. I told you that the volume did not matter as long as we are consistent. Are we consistent here? No. So I've got to change one of those. What I'm going to do is, when I do this, I'm just going to make my liters. Since it's 1 liter, I know that 1 liter is equal to 1,000 milliliters. So I'm just going to make that into 1,000 milliliters. But I write down my equation. And I know that when I'm doing a dilution, M1V1 is equal to M2V2. I come back up to my problem. Well, I see M1 is 1.6 molar, and I multiply that by my volume of the first one, which is 175 milliliters. That's going to be equal to M2, which is what I'm trying to solve for. And here's where I made my conversion. I diluted it to 1,000 milliliters. So just some simple math here. In order to solve for M2, I've got to divide both sides by 1,000. I get a cancel there. I divide this side by 1,000. And M2 is going to be equal to 1.6 times 175, and then I'm going to divide that by 1,000, and I get a value, and I come back to my original 3 sig figs, 2 sig figs, 2 sig figs. I need 2 sig figs. I get a value of 0.28. Now I go back and look. Milliliter over a milliliter, that cancels. So that leaves me a label of M. So my M2, once I've made this dilution, my answer is going to be, my new concentration is 0.28 molar lithium chloride solution. Now, I predicted that the molarity would go down, right? Did it? It did indeed, right? Did indeed. Go ahead and write this down, and then we will work it. I have 345 milliliters of a 1.5 molar sodium chloride solution. If I boil the water until the volume of the solution is 250 milliliters, what will the molarity of the solution be? So in this problem, am I actually diluting it? I'm not, am I? I'm making it more concentrated. But does that matter? Will my dilution equation still work? Absolutely. Okay? So I'm making it more concentrated. So what do I expect to happen with my molarity? It should go up, right? So once again, I'm going to do M1V1 is equal to M2V2. Well, my M1 is 1.5 molar. My V1 is 345 milliliters. My M2, that is what I'm trying to solve for. My V2 is 250 milliliters. Now, before I go on, I'm going to make a mental note that when I look at my values, I have 2 sig figs. That way I don't have to come back up here and look in the equation again. So I'm going to solve this, and I'm going to have 2 sig figs. So what I'm going to do, I'm going to divide both sides by 250 milliliters. I get a cancel here, 250 milliliters. So my M2 is going to be equal to 1.5 times 345, and I divide that by 250, and I said my M2 should be going up, right? So when I did my math, and with 2 significant digits, I came up with a value of 2.1. My milliliters cancel there. So I have now, by boiling off that water, I have created a 2.1 molar sodium chloride solution. Not too tough, right? Okay, here's our last example we're going to work, and this one is a little bit different. So go ahead and copy that down, then we will work it. A 40.0 milliliter volume of a 1.80 molar iron 3 nitrate solution is mixed with 21.5 milliliters of a 0.808 molar iron 3 nitrate solution. Calculate the molar concentration of the final solution. Now, this problem, ladies and gentlemen, I'm taking 2 different molarities and 2 different volumes and mixing them together. So I am not using M1V1 equals M2V2 because I've already got all of that information. What I'm doing is I'm taking 2 different solutions and combining them. They're 2 different solutions of the same solute. So I still have iron 3 nitrate, but I have 2 different molarities of iron 3 nitrate. Now, when I combine them together, doesn't it make sense that I should have a value somewhere in between those 2? So I should have a value that's in between 1.80 and 0.808. What I need to do first is I need to find out how many moles are in each one of those solutions. So I know that my number of moles is equal to my molarity times my liters, right? So I'm going to take my molarity, 1.80 molar, and I'm going to convert this to liters. 1, 2, 3. 0.040 liters. So that will tell me when I do my math, 1.80 times 0.040, that gives me 0.72 moles in that solution. Now I'm also going to calculate the number of moles for my second solution. So I'm going to take the 0.808 molar, and I'm going to multiply that by 0.0215 liters. And when I did that, I came up with a value of 0. This is wrong. I got to go back. I forgot to put a 0 in there. 0.072 mole. My bad. 0.017327 moles. So I have the number of moles in each one of those. What I need to do now is I need to find the total number of moles. So I'm going to add those two together. So it's going to give me 7, 2, 3, 9, 8, 0.0. So my total number of moles are 0.089327. Now, I know that I took 0.040 liters and 0.0215 liters. So I know that 5160.0. My total volume is 0.0615 liters. Well, if I have moles and I have liters, I can get molarity, right? So I'm going to take 0.0893327 moles, and I'm going to divide that by 0.0615 liters. And when I divide that, that's going to give me my molarity of the entire concentration. So 0.089327 divided by 0.0615, and I get a value of 1.45247, and that is going to be molar. So I need to come back up. I didn't make a mental note. Come back up, and I see 3, 3, 3, 3. All of those have 3 sig figs, so my molarity is going to be equal to 1.45 molar. Now, I predicted that I would have something in between those two values. Is it? Absolutely. So when I mix those, it's got to be in between those two values. So when I mix those two different molarities and the two different volumes together, I found the number of moles in each and then divided by the total volume to get my new molarity. You're going to see that on WebAssign. So make sure you refer back to this example when you see that again.